Okay, hello. Section 5.2, mean variance standard deviation expectation. Okay, so the mean variance standard deviation for probability distributions are comprised differently from the mean variance and standard deviation for samples. So in here, we are more focusing on the probability distribution. So mean, how would you compute the mean number of spots showing on the top of the die when it is rolled? So in order to do that, okay, so we are doing the problem in number one, okay? So tossing coins. Suppose we consider tossing coin 2 times. We do the 2 times and then list the sample space. So sample space will be, you'll get as, could be the head for the both and the head and tail or tail, right? I think that's all, right? So in a long run, you would expect two heads to occur about 1/4 of the time, and one head and one tail about 1/2 of the time, and no head will be the 1/4 of the time, which is 2 tails. On the average, the number of the head will be 1. So look at the probability distribution of the number heads when the coin is tossed an infinite number of the time. So 0 head means, of course, is a 1/4. But one head, because the 0 head is a tail. And then one head could be tail or tail head hair. So 1.5, which is 2/4, which is 1/2. And then 2 head is going to be another 1/4. All right, so in order to find the mean for this one, so mean is going to be we are using the same formula we have. So sigma sub of x times p of x, which is you multiply individually 0 times 1/4, 1 times 1/2, and 2 times 1/4, which come out as 1. So rounding rule for mean variance and the deviation of the probability distribution, we're going to round it to 1 more decimal place than the outcome x. Alright, next page. A formula for the mean of a probability distribution. So the mean of the random variable with a discrete probability. So this is a formula. I just use it. Okay, so this is what we're gonna use. And then the where the x of 1 and 2 and 3 will be up to then here. Alright, rolling a die. So this time, probability distribution to find the mean number of the spots that appear when a fair die is tossed. So getting 1 is 1 out of 6, 2 out of 6, 3, 1 out of 6, up to 6. So in order to get a mean, will be the sigma sub x times p of x, of course. So you can do that as 1 times 1, 6, 2 times 1, 6, 3 times 1, 6, 4 times 1, 6, 5 times 1, 6, and 6 times 1, 6, which is 7/2. And then becomes 3.5, okay? Which is more, you can just use a 6 in here, so it becomes 21/6, of course, come out to 3.5. So that's a mean. Number 3, number of the trips for 5 nights or more, trips of the 5 nights or more. A study concerning the number of the trips of the 5 nights or more that the American adults take per year shows that 6% did not take any trip lasting 5 nights or more. 70% takes 1 trip at least lasting 5 nights or more. 20% takes 2 trips lasting 5 nights or more. And 3% takes 3 trips lasting 5 nights or more. So while only 1% take 4 trips lasting 5 nights or more. Fill in the chart, which means that family loves to actually travel. Fill in the chart to find the mean number of the 3 American adults take per year. So 0% the 0 is gonna be there's the family that never take the 5 nights and more trip, which is gonna be 6%, so probably it's gonna be 0.06. And then this from here, and then 70% take the at least one trip lasting 5 nights or more. And then the two trips with that is a 0.20%, 0.20. And then 3% said that they get 3 trips. And then 1% said that they get 4 trips. Four trips that make a lasting 5 nights or more. All right, so same thing now. In order to be the mu, which is sigma of x times p of x. So you got 0 times 0.06, 1 times 0.70, 2 times 0.20, plus 3 times 0.03, plus 4 times 0.01, and then I got 1.23. Alrighty, that's it. So rounding rule, same thing. Yeah, you should round one more decimal place than the outcome x, but with a fraction, you have to put that as a lowest term. Okay, let's talk about variance. Variance and then standard deviation, you just need to put the square root on the variance. The mean gives a long run average but does not describe the spread of the distribution. Thus, we need to calculate the variance and standard deviation. The formulas from the chapter 3 cannot be used for the random variable of the probability distribution. So I'm giving you another formula here. So it does variance, you have to use this formula. Standard deviation, just put the square root on the top of it. Okay, so pretty simple. But you can do this, but it will take a while. Okay, and then it will take a while. So in order to find the quickly computation, I want you to use those the computable the answers. So this is easier. So I want to do this too. Also, so now let's do the example 4 as a rolling die. So when you use a probability distribution to find the mean number of the spot that appear when a fair die is tossed. Earlier we found that the mean probability distribution was 3.5. So we're gonna use those. Okay, so mean of the probability is 3.5. So mu was already the 3.5. So we're gonna find the variance and then the standard deviation. So for the variance first, so as a variance, we put the sigma square, which is a sigma of the computation works, okay? So x squared p of x, and subtract the mu square. So the first terms of the computation is we are doing the squared all the x's here. We squared all the x's here and then multiply by each of the probability and subtract the mu square, okay? So I do 1 square of 1 over 6, 2 square 1 over 6, 3 square times 1 over 6, 4 square 1 over 6, 5 square 1 over 6, and 6 square 1 over 6. And then you will get, and then you gotta subtract your mu, which is what, 3.5 square. So when you simplify that, I get the 91 over 6 minus 35 squared is 12.25. And then use a calculator, 2.917. That's a variance. And then in order to get a standard deviation, which is a sigma, which is plug in the sigma square in it. Sigma square now come out 2.917. And then it's about the 1.708. Okay. All right, next problem. Number of the tip lasting 5 nights and more. So I'll do the another way, which is we are using this form, so which is the same problem. You know what I need? Okay. All right, now yeah, so we just had a problem here. Okay, so same thing. But this time I'm using another table to instead of the plugging it in, why don't you use a table to compute this first? So as a zero, outcome as a 0, 1, 2, 3, 4, and P of X is the first one 0.06, 0.70, 0.20, 0.03, 0.01. Of course, it becomes 1 as a total, and multiply the x and p of x to get x times px, which is you got 0 and 0.70, 0.40, 0.09, 0.04, And then x times p of x becomes 1.23, which was the mean. So this was the mean, right? And then you x squared the p of x, so you squared all the x's, okay? So you got the 0 and 0.7, 0.8, 0.27, and 0.16, you got the 1.93. Okay, so now to get the variance, it's a sigma of x squared times p of x minus mu squared. So we already got the sum of this one, which is 1.93. So I put the 1.93 minus of 1.23 squared, which is 0.4171. And then sigma is, you put the square root of the sigma square, which is 0.4171. You get the you get the 0.6458. All right. Okay, next page. Now, expectation is the same thing. So expectation is the same thing as finding the mean of the probability distribution. Okay, so expectations. Expected value or expectation is used in a games of the chance insurance, another area such as decision theory. Expected value denoted by E of x is another name for the mean of the distribution. Thus, the formula is mu equal to E of x is the same as sigma x times P of x. In a gambling games, an expected value of the 0 indicates a fair game. If the expected value is a negative, the game favored the house and the player will, in the long run, lose money. If the expected value is a positive, the game favored the player and the player will be, in the long run, win the money. So, dice game. A person play $3 to play a certain game for rolling a single die once. If 1, 2, 3 comes up and then the person win nothing, which is losing money actually, right? So as if the roll come out as 1, 2, 3, losing money, which is $3. If, however, the player rolls a 4, 5, 6, he or she wins the difference between the number rolls and then $3. So $3, 4, which is a $1, the earning, which is still losing $2, right? Then 5 means $2 earning means still $1 losing, and then $3 here. And then each of the chance to get the outcome is 1/6. So expectation value, which is the same as sigma sub of x times p of x. So in order to multiply the 1 times or -3 times 1/6. Let's put the negatives immediately. -3 times 1/6. I'm multiplying this the gain x to the probability. Okay, it's the probability. -3 times 1/6 and 1 times 1/6, 2 times 1/6, and 3 times 1/6. So when you compute them all together, okay, and then you get the 0. So in the long run, the player will not lose any money. So conclusion is, if that's the case, a player will not lose money, and the game is fair. Okay, so let's go to the next problem. Insurance. An insurance company issues a person's antique coin collections worth $20,000 for an annual premium of $300. If the company figures that the probability of the collection being stolen is going to be 0.002, find the company, which is 0.2%, which is this is hard to lose the coins. Find the company's expected profit. So the amount company earning gains or loses x. Okay, so the company's still earning the $300, but if the company lose the coin, need to pay to the 200,000 to the person, which is the percentage of 0.002. So other percent is going to be the 0.998 will be the not losing the coins. Okay, so which means what? The company can keep the 300. So in order to find the expectation, which is this becomes negative 19700. So negative 19700 times by 0.002 plus 300 times of 0.998, and then you'll get the 260, which is still the expected value from the company is going to be 260 annually. Okay, so that's why the insurance company makes the money. All right, thank you for listening.